Okay, so we're going to start with a probability problem. So like we've been doing for multiple choice and free response, I want you to read the problem. That's really important. And as you read, I want you to underline, I'm going to highlight, but I want you to underline kind of the important things as you read. So this one says, in humans, curly hair is dominant to straight hair. So that's going to be important to me. Curly hair is dominant to straight hair. A woman is heterozygous for hair curl, and she marries a man with straight hair. They have children. So from this, even this first part of this information here, I know a couple things. I know curly is dominant to straight, so that is telling me, we're doing basic Mendelian genetics here, and that the woman is heterozygous for hair curl, and the man has straight hair. So the first question here is, what is the genotype of the mother? Genotype. And what gametes does she produce? So the reason why I did genotype is I'm going to remember that genotype is like gene, which is the letters. So because it's dominant and recessive, I'm just going to use a capital and lowercase. You could use a C for curly. Because the C is a little bit harder to differentiate between the capital and the lowercase, I'm going to use H for hair. So we're going to look back up and it says the woman is heterozygous for hair curl. So if she's heterozygous, remember, hetero means different. So that means she has a big H and a little h because she is heterozygous. If it said she was homozygous, homo means the same, she would be big H because she has curly hair, which is dominant. Now, the second part of this question says, what gametes is she going to produce? And we're going to remember that in meiosis, the two alleles separate. So she's going to give off one allele that is capital H and one allele that is lowercase h, like that. All right, the second question here says, what is the genotype of the father and what are the gametes? So kind of the same question. It's just talking about the father this time. The father here, it says he has straight hair. So because curly hair is dominant to straight hair, the only way for him to have straight hair would be if he is homozygous recessive or little h. That's the only way for him to get that recessive trait. And then again, we're going to remember the gametes is when the alleles separate. So you're going to get a little h and a little h from dad. All right, next question. What is the probability that the first child will have curly hair? So it's asking the probability of curly hair. It says the first child there. When it asks for probability, sometimes it wants a fraction, like a 1 in something, or sometimes it wants a percent. So I find it kind of easiest to give both. So in order to figure that out, though, I'm going to have to do a Punnett square. So I'm going to do it on this side to show my work. So I'm going to draw a Punnett square. And lucky for us, in part A and B, we figured out the two gametes. So I'm going to put mom on the side. She's big H, little h. And dad on top. So again, we got that from part A and B. And then remember to fill out the Punnett square, you do top, side, but the convention is you do the capital letter first. So that is how the Punnett square is going to fill out there. So with that, I can answer part C. It says, what is the probability that the first child will have curly hair? Remember, curly is dominant. So what I'm seeing here is right here, this child's going to have curly hair. And right here, this child's going to have curly hair because they have two dominant big H's. Down here, they're double recessive, so those are actually going to be straight hair. So I'm going to say that 2 out of 4 chance, because we have 1, 2 out of 4 total, that the child will have curly hair. And then I can actually, and I should, simplify that to 1 out of 2, think like fractions. And then what I always do just to cover all my bases is I also include the percent, which a 1/2 or 1 out of 2 is going to be 50%. Now, this last part says, what is the probability of the second child having curly hair? Now, this is here to trick you, especially because they said first and second. What they're trying to trick you and say is kind of like we said before, like, oh, well, if one of the kids has curly hair, then one of these goes away. And now there's only one left, kind of, right? But we're not going to be tricked, and we're going to remember that every time you have a child, those probabilities and those Punnett squares happen every single time. So the results of the first child have no effect on the second child. So again, the second child has a 2 out of 4 chance to have curly hair, which you can simplify to 1 out of 2, which you get the percent of 50%.